All right, so now we're going to graph an equation, a quadratic equation that has all the parameters in it. So example 3, we're going to graph y equals x squared minus 4x minus 3. And we're going to use a table of values, but before that, we're going to calculate the axis of symmetry and the vertex. That's the first part of this. So whenever you get a problem like this, the first thing we're going to do is calculate where the middle of this parabola is. We're going to calculate negative b over 2a. Well, in this problem right here, the a value is 1, the b value is negative 4, and the c value is negative 3. So we can go ahead and calculate this out. We could say this is negative b, which is going to be negative 4, so this would be positive 4 over 2a. And a is 1, so this would be over 2, because that a value is 1. So I have 4 divided by 2, which is 2. So that means that my x equals 2 here, and that this right here is my axis of symmetry. And when it comes to my table of values that I'm doing over here, it is going to be best practice to be the first value that I plug in. So what should I plug in for x? The first thing I'm going to do is plug in 2, because I want to know what the y value is for that. I know what the x value is. So I'm going to take 2, and I'm going to go ahead and plug that into my equation. You know, you can just do it mentally. You can use your calculator to speed things up. But if you plug in 2 there, you get 2 squared minus 4 times 2 minus 3, and you're going to get negative 7. So the key point of this problem is actually the first point that you find, right? If I plug in 2, I get negative 7. This right here is the vertex, and that is the most critical point of the graph. So we're going to plot that first, and we're going to go, so 2, negative 7. So that's down here. And we also know this is the middle of our graph. So if you want to, you can actually put a little, dotted line in here, like right through x equals 2. And I would make sure it's like a dotted line so that you know it's not actually part of the graph, but it's the center line for it. Now, we know that since the a value is 1, right, it's a positive a value, that this thing is going to be going up. So I know my parabola, my vertex is right here, and I know it's going to be going up like this about, right? But to make a better graph, I'm going to plug in some points actually there. So what I want to do is plug in x values that are close to the vertex, and I'm going to work my way out. So I have 2, I'm going to work my way out, and maybe I'll try, well, what happens if I plug in 3? So I plug in 3 into the same thing, and I have 3 squared minus 4 times 3 minus 3 is negative 6. So 3 goes to negative 6, that's right here. And then I'll just keep working my way out to get a few more points that are going to allow me to make a smooth curve. So what happens if I plug in 4? Well, 4 squared minus 4 times 4 minus 3 is negative 3. So 4 goes to negative 3. So that's right here. And let's just plug in another one that, let's just go with 5. Let's try 5. Let's see where that takes us. So 5 squared minus 4 times 5 minus 3 is now 2. So 5 goes to 2. And so that's up here. And we could plug in 6. If we wanted to. So 6 squared minus 4 times 6 minus 3 is now 9. And so that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. That's up here. And so we basically have, if we plug in 6, we get 9. We have half of the parabola right now. Okay, so if I graph this, I could sketch this part right here, and that's half of the parabola. Because we know this is symmetrical, we can get the other half very quickly, right? We can just take this point, each one of these points, and reflect it over. So this point right here, I could just flip it over this line, and I know this point is going to exist right there. The same thing. So I know that this point, if I plugged in x equals 1, I know it's going to be the same output as x equals 3 because they're symmetrical about that line. So I'm going to put this right here. If I plug in 1 here or 3, I would get -6. And what about the 4? If I plug in 4, I get -3. But if I use symmetry here, then I know that this point is also going to exist right here at 0. So I know that 0, if I plug that in, is going to give me the same output as 4, which is -3. And if I flip this point over, I know I'm going to have -1 is also going to go to 2. And if I look at this point up here, which is at an output or y value of 9, right? 6 gave me that output of 9. If I just go over now and use symmetry, I'm going to go here, and it's 1, 2, 3. It's 4 spots away from the line. So 1, 2, 3, 4. -2 is going to give me the same output as well. So we can use symmetry and use that line to generate more points without having to just do the exact same process and plug it into our calculator or whatever we need to do there. So now I can sketch this as best as I can, and now I have a nice looking graph. Okay, so if we look further into the problem, it says calculate the vertex. So the vertex here, if we put a summary here, the vertex, we already calculated, it's above, but to -7. That's the main thing that we do when we start this problem now. Okay, and that is always gotten from starting with -b over 2a. Okay, then it says identify the domain and range and the min and the max and the axis of symmetry. Let's start with the axis of symmetry, right? The axis of symmetry is basically just this line right here that we already calculated. The axis of symmetry is just that -b over 2a number that we calculated was 2 right here. So the axis of symmetry is just going to be written as x equals 2. So those are the main pieces. We have the graph here, we have the vertex and the axis of symmetry. Some other things that it asks for that we'll talk about is the domain. Okay, so what about the domain of this graph? The domain is basically which x values could I plug into this function? Or if I look at the graph right here, which x values are being graphed? And the answer to this is all real numbers, because this graph is spanning to the left and to the right. If I took this and you were looking at all the graphed values, and you were to take the whole graph and bring it back down to the x-axis, you would see that you would graph every single value on the x-axis here. In other words, if I said, hey, what could I plug into this function, right? What could I plug in for x? There would be no restriction there. You can plug in any number. There's going to be no errors. There's going to be no weird square root of negative something that you take there. Anything is allowed. So that's why we put all real numbers. Now it asks for the range as well. Now the range is going to be which y values am I graphing? Or which y values am I getting here? It's best to look at the graph here and look specifically at your vertex. Your vertex here, the lowest point of our graph is right here, which is at -7. And we're graphing everything above that. So my range is going to be the y values that are greater than or equal to -7, because you can see that on the graph. It also asks for a minimum or a maximum. So let's talk about what a minimum or a maximum is. A minimum or a maximum is going to be, in this case, we're going to have a minimum because we have a low point on our graph, right? If the graph was going like this, we would have a maximum point or a high point. So I'm going to say we have a minimum here, okay? A minimum value of, and this is basically asking the question of how low does the graph go? In terms of the y values, how low does this thing go? So again, that goes right back to my vertex. That goes right back to the this value right here. Not the 2, but the y value is -7. So the minimum, the smallest y value that I could get is -7 there. So that's what we would put. So this is the main stuff right here. Okay, you should be able to graph this thing and say, hey, the vertex is so-and-so, here's the axis of symmetry. And then these are kind of the secondary questions that you should also be able to answer based upon the vertex. You can see everything kind of revolves around the vertex. The domain is never going to change for these types of functions because in a quadratic equation, you can plug in any number that you want. So the domain is going to remain consistent at all real numbers. But the range is going to be based off of the low or the high point of the graph, and it's either going to be greater than because we're graphing everything above it, or it could be less than or equal to because we're graphing everything below it. And then a minimum value here, or a maximum value, is really, again, based off of that critical vertex point. I want you to go ahead and try this next one, practice it, pause the video, see if you can go through and find the axis of symmetry in your vertex, fill out your chart, and graph this thing. So pause it, see where you can go. Okay, so this is what you should have done for this graph. First thing is, as always, you're going to graph the axis of symmetry, or find -b over 2a, which in this case, -b is going to be +8 divided by 2a. That'd be 2 times -2, which is going to be 8 over -4, which is going to be -2. So I know my axis of symmetry is x equals -2, and then I'm going to start to plug this in and put -2 into my x value. And if I plug in these values, -2, I get 9 for my output. So -2 goes to 9, that's up here. I know this graph is going to open down, so it's going to go like that, but I want to pick some more points to make it look good. I do know that the axis of symmetry here is going to be right in the same spot, so I'm going to make a little line there. And then I need to pick some more points. I'm going to start at x equals -2 and just work my way out. So let's just try to go to the right of that. So if I plug in -1, I would get 7. All right, so -1 goes to 7, that's down here. I'm going to use symmetry right away. So I know that this goes right here, but then also this point has to exist over that line. So I know that -3, if I were to plug that in, right, is also going to give me 7. So then I'd go to 0, and I'd say, what happens if I plug in 0? And that's going to give me 1, of course. So that's all the way down here. And I would use symmetry to say that this point over here has to exist at -4. Has to work as well. And that's good enough to make your parabola. We can probably do one more. If I plugged in 1, you get -9. So 1 all the way is down here, and then I can use symmetry to say that -5 is also going to give me -9. So now my parabola is going to be like this, where we have the vertex at -2, 9, and we have my axis of symmetry is at -2, and there's what the graph looks like. So to summarize here, I have my vertex at -2, 9, My axis of symmetry is at x equals -2. My domain, remember that's going to stay the same. That's going to be all real numbers or anything there. The range is going to be the y values. Since the graph is going down, it's going to be less than or equal to 9, right? Because the highest point of this graph is at 9, and I'm graphing everything from there and below it. And then the other things it asks for, what about a maximum or a minimum? Well, in this graph, we have a maximum value, not a minimum value. We have a maximum value because, just look at the graph, we have a high point. And so we're going to say we have a maximum, we have a max of, and all we're going to do is state the highest point or the y value of the graph. So we're going to say a maximum of 9 there. So there's all my extra little questions that I might have to answer, and here's my graph of that equation.